Let's do it. Well, welcome everybody this afternoon. This is Steve Dicus, live and direct. Hey, real quick, while we're waiting for other people to jump on, if everybody could just tell us just your name and what school you represent, and just go around, and then we're going to have Karen start the presentation. So, Roy, you want to kick us off?
Sure. Roy Ingram, Sierra College, Mechatronics.
Tyler Hickox, Sierra College Engineering.
Ryan Grigsby, Shasta High School, Robotics.
All right, going back to more. Ooh, the sun came out. I think I can turn off a light or two. That'd be nice. Okay.
Right.
All right, so I'll talk to you a little bit later, okay?
Okay. All right.
Okay, thanks.
Bye.
Anybody else want to introduce themselves?
This is Matt Wynn, Casumnas Oaks High School, Engineering and Building Trades.
Hey, Matt.
Dept Smith, I'm with Chaffey College InTech Center in Southern California, crashing the party today. I was invited by Jeff to attend, and we run mechatronics, industrial electrical, and mechanical welding and other trade programs through our technical center.
Excellent. We're glad you're here and welcome.
Thanks for the invite.
So I think we've got just everybody that's currently on the call, and we'll have other people join as we go. But I wanted Karen Fraser Middleton to start us off. Last week, she showed us some of the resources that we've been posting on the website, edu2manufacturing.org. And I asked her to kind of walk us through where they're being posted and what's on there, just as a resource for you as educators. And you just share it for everybody. The more resources we put on there, there's a great repository in helping us going forward. So Karen, do you need to share the screen?
Yes, that'd be great. Good afternoon, everybody. I'm Karen Fraser Middleton, and I work with Steve and Jeff. I send out the newsletter that some of you may get, and I've been helping them post information on the blog. So I'm going to show you that as soon as you stop sharing the agenda. And I'd welcome if you have information that, you know, we should be posting. Like Dee's been really great about sending information from Autodesk, so we've been able to post that. If some of you found some really good websites that have been useful, we can add that as well. I'm also interested in your YouTube channel so that we can share those. So, but my main goal right now is to show you the website. So hold on. Sorry, I've got like multiple screens going on here.
Well, Karen, while you're doing that, I'm going to just let everybody know. I'm going to mute everybody. There's a lot of background noise, and then anyone who wants to chat or chime in can just unmute themselves. Sorry about that.
Here we go. Sorry, it took me a minute to find where I was. So this is the EDU to MFG website, and it's EDU with the number 2 MFG.org. And when you go to it, if you go to the news, which is either here in the middle or news up here, that gets you to the blog posts. And so there's a lot of different blog posts, but the thing that you might be most interested in as instructor is down here in the categories. There's something called instructor resources. And so what we've just started doing is taking these shop talks and putting them on a YouTube channel so that you'd be able to access those. So if you missed one and wanted to go back and listen to them, this would be an easy way to find them. So last week's is the one on the 21st. And so I actually just posted all these this weekend, so they're all right here. And then we also, on this this one, we listed all sorts of teaching resources that you've shared with us. So we're trying to make it easy for you to find the things that you've shared with each other. So Steve had put together a nice long list. And so you can see that there's all sorts of links, you know, electronics, machining, drafting, using Autodesk, and all the links are right here on the blog post. So it would be a fast and easy way for you to be able to find those. And then you can just scroll down. So these are all grouped by instructor resources. And so Dee had also given us, like, this is an example of some of the Autodesk links, and they have a bunch of webinars going on. So we've listed those. So if you have other resources like that, we'd be glad to show those. And if you're just wanting to find the Shop Talk, we did set up a YouTube channel that's EDU to MFG. So you could just, if you want to just jump from Shop Talk to Shop Talk, you can listen to those as well. What I can do is I can put the link into the chat so that you would be able to go directly to those resources and have those as an option. Are there any questions? Great. Well, thank you so much, and just let me know if there's anything else that would be helpful. We'd be glad to put it up.
Yeah, thank you very much, Karen. So we're trying to have a repository or a place where we can go back to, because I know everybody's trying to figure this out as we move forward, and it'd be nice to be able to go back and, ooh, that's right. Somebody talked about this 2 weeks ago or 3 weeks ago. Now it's relevant to what I need, so that'd be really cool. So thank you, Karen. So next up is John Zay from Sacramento City College. He's got 2 programs he's going to spotlight here for a few minutes for us. And then after that, Ken Gracie is on the line, and I are going to talk about the virtual tour that we're proposing doing here shortly. So John, take a few minutes, and do you need to share the screen, or what do you need? John, you're muted, so we can't hear you. Jeff, can you unmute John?
I think I'm unmuted. All right, let me just go ahead, and I will need to share this screen. Okay. So, do you see?
Not yet.
Okay. Do I have to take over? So, let me. I'm not quite sure how this is going to work. Okay, so I'll take the screen. And
is it just screen share on the bottom?
You're right, hit share.
There you go.
So you see that. Now I'm going to try to
there you go.
Activate it. So you don't see it anymore though, do you?
No, I see it. Well, I see it now.
Do you see the whole PowerPoint, or?
I just see one page of the PowerPoint. Heating and ventilation, air conditioning, and refrigeration.
Okay. All right. So Sacramento City College has 2 programs. One is the MET. There we go. How's that? One is the MET, Mechanical Electrical Technology, and the other one is the IMMT, which is Industrial Maintenance Mechanic. That is the one that we're starting in the fall. So the MET is actually for HVAC, and it's a name that's rather traditional from back in the 50s. So, and we are a hands-on training program. So I guess the big question is, what's HVAC/R, right? And HVAC obviously stands for heating, ventilation, air conditioning, refrigeration. So, and the systems that we prepare our students for are for commercial. And it ranges from strip malls to multi-story buildings. And in the multi-story building, the photograph, you can see all the individual components that make up a commercial HVAC system. So the heating on here is, most of us are familiar with residential furnaces, which is on the left. But in commercial HVAC, we do use some gas-fired furnaces, But we also use boilers that can either heat water or make steam. So this is an opportunity for people to learn not only how to repair boilers, but also operate boilers, because any boiler that operates over 15 psi in pressure has to have an attendant on duty. That's state law. And by the way, the boiler plant is our lab, one of our labs. Ventilation is the ductwork that moves the air around, which is an extremely important component. So in a large building, you might see on the left is an example of something that's exposed that delivers the air. And here you need to know how air patterns flow and how to adjust air. And on the right is another open exposed ducting system. But typically, when you go in an office, that's all covered by the ceiling. So most people don't even know that exists. But that's the ventilation part. And that's where we deliver the conditioned air plus the filtered air. And in air conditioning, we're all familiar with the window units, right?
Yep.
So in the commercial world, a lot of times on the smaller buildings, we have rooftop units, which you can see right there. And they're typically called boxcar units. And that's where all the conditioned air comes from, whether it's heated, cooled, filtered, it all comes out of these boxes, go through the ducting into the individual rooms in the building. So the technicians, the students learn how these systems operate, how to troubleshoot them, and how to repair them. And then another couple forms of, and I'm going to say air conditioning because we assume that means cooling. But we have on our left is the greatest in technology is the variable refrigerant flow, which is kind of cool because that heats and cools simultaneously. And again, that we're in partnership with Train to provide that type of training to our students. And it's a pretty cool piece of equipment. And on the right is what we call a chiller plant. And here is where we make chilled water or cold water. And we'll run this water through coils similar to the radiators in your car. And that will absorb the heat out of the air. And that's how we cool buildings, the very large buildings. And both of those pictures represent labs that we have in our training program. And this one's a little bit out of sync, but this was on the that boxcar unit. The reason that was being worked on is that it had a bad contactor, and you can see right in where the arrow is pointing to, the blue arrow. That's a contact, that's electrical contact, and it's black, so it's burnt where it should be a nice brass color. So the technician goes in and troubleshoots these issues, and then they replace the parts that are defective, and then tries to find out why that part failed. And so the big systems, you know, at home, we control our heating and cooling by thermostat. But in big systems, we use what's called a building automation system, or a BAS. And here's a picture of a screen that's for a BAS system, and it has graphics that show different operations of the various parts of the system. And so, and this is all done by a combination of hardware and software. And the picture on the left is the hardware. That's what's actually making the system work. But on the right is somebody has to go in and program the hardware. And this is a computer, the screenshot of a software program that the students learn how to program the BAS controllers. And this is something that's needed quite highly out in the field. So, and refrigeration is kind of its own little animal. in refrigeration, in commercial refrigeration, a lot of it's meat packing plants, grocery stores, and things like that. And so the refrigeration technician or mechanic, they are either installing new equipment or repairing existing equipment. And the shot on the left shows a condensing unit being lifted up onto a roof on a probably to replace an existing unit that's up there. And the shot on the right, it's in a grocery store. In that case the gentleman's walking on, they're actually putting on glass doors. It used to be just an open front, but they're putting on glass doors to make it more energy efficient. So, and then repairing equipment on the right, or excuse me, on the left, a fan blade came apart. So that needs to be replaced along with whatever it damaged in the process that's coming apart. And then on the right, the gentleman who happens to be my son is welding in, or actually brazing. We don't weld, we braze. Looks like a new compressor, but he's brazing refrigerant, copper refrigerant lines. So I think you can start seeing as we go through these slides, there's a lot of different skill sets that are needed to work on this equipment. So, it speaks for itself. That misting is refrigerant coming out of a broken line, and it's below freezing, so it tends to freeze the moisture in the air, causing the air to turn white, and a lot of other things it comes in contact with. So, and that's in a supermarket. Whoop. Oh, here's another one. So this is in the mechanical room. This is where a lot of the heavier parts of a refrigeration system is in, and you can see it's rather noisy. They're losing a lot of refrigerant, and you can see how the air is kind of foggy, and that again is because the liquid refrigerant coming out of the system, its boiling point is way below 32 degrees. Actually, it's way below 0 degrees. So it's freezing all the moisture in the air. All right. So again, this is something a service technician would do, would find the leaks and repair them, and then put refrigerant back into the system. And that's pretty much for the MET program. Now our new program, Industrial Maintenance Mechanic, which again starts in the fall, is really to provide technicians, maintenance mechanics for the food processing and the manufacturing, advanced manufacturing companies here in Sacramento, in the greater Sacramento area. And as we can see that over the years, the way that we handle our product is becoming less and less labor intensive and more automated. So, and maintenance mechanics, they'll also fabricate material. You can see the lady on the left is using a grinder to cut a piece of metal, and the person on the right is actually aligning a pump to ensure that the two shafts align within tolerance. So there's no premature wear of the equipment. And then this shot is here locally. The piece of equipment on the left is it's a rock shaker. So when rice comes in from the field, it has little pebbles in it, and the rice falls down from the top. It shook, and then the little pebbles of rock fall out into the red buckets. Right? and then the rice goes on to be processed. So this equipment is all controlled by PLCs, programmable logic controllers, right? Which is, there's a high demand for people to be able to program, install PLCs. And then the PLCs that we'll be training on is Allen Bradley, because that's what industry uses. And then this screenshot on the right is what a program would look like, that the person who programs a PLC controller would have to go in and configure the logic to make the PLC do whatever the system calls for. So, and then the other part of the program is robotics. Robotics are really big, except the robotics in most of the food production and advanced manufacturing at this point in time don't have wheels. Okay, they're fixed, and but somebody needs to program these. Somebody needs to repair them. Right? And then here's and they're using a PLC for packaging. Okay. So, and the last part is that we also started a CNC machining program about a year ago. So, and we use Tormax, and so that just kind of complements the industrial maintenance technician program that we have. So, I think hopefully you get a good flavor of what a HVAC refrigeration technician does, and kind of what they have to learn along as well as a industrial maintenance mechanic. And then it's our goal to teach, our goal is to teach the student the skill sets necessary to have entry-level skills. And do you have any questions?
John, this is Dicus. I've got a question. So how are you guys set up for doing distant learning for the fall if it comes to that, and that's the way you're going to have to present this to students?
Well, I know for the HVAC, we're going to use Cengage, has some simulators that we're going to use. Some of our classes, it's fairly easy to go from face-to-face to online. And as far as the hands-on lab, is that we will we're still working on that. But yeah, that's a tough one. That's a tough one for all of us. But I'm thinking, this is time we think out of the box. And I was talking to an associate of mine in San Francisco, and one of the things you could do is you could buy some low-cost throwaway wrenches, buy some bolts and nuts, and say, okay, now break the bolts, all right? And, that might sound kind of lame, but that's one thing we do a lot. We tend to break bolts because we tighten them up too much, all right? So now, because this, and then students sometimes, this may be the first time they hold a wrench. So now they get to feel that. They get the feel of the wrench. And then they start to learn those skills of how much torque to apply before something breaks. I mean, that's what we learn out in the field. And because trust me, the specs may call for something to be torqued down, but the odds are the torque wrench is somebody's hand. Okay, and that's just right, wrong, or indifferent. That's just kind of how it works. So there's these little lab assignments that we could send home, and the students could do them. And then we're going to price them in such a way we don't even want the material back, right? But again, I think it's all about thinking out of the box, and then also realizing we're a 2-year program. So when they come back, then we'll you know, we could actually allow them share the labs and open them up to where they could actually do on lab, actually face-to-face lab projects. Right? It's going to be tough, and it's not going to be perfect, but we just have to do the best we can. All right. And the other thing, Steve, is we meet every Friday night at 7 o'clock as a department, and now we've gotten over some of the past hurdles. Now the new hurdle is sit down and brainstorm on Friday nights on how to or what to do in the event we have to go back face to face. I mean, back to online.
John, thank you very much for the presentation. We got to move on, but just real quick for everybody listening, you know, they've got an AS degree that they offer as well as several certificates in their program. So Sac City's kind of rocking it. And this is where I would send a lot of my students that had a mechanical aptitude and they're looking for something to do and solve problems. And I don't think any of these careers are going to go away in their or our lifetimes. So
no.
So we're going to transition to the next thing. Thank you, John.
Thank you.
And so you can leave your screen up if you want. I don't have anything to share.
Okay, I'll figure out how to do that.
I just did it. So here we go. I'm just going to go to my screen. Or Jeff, you can put the agenda back up. But real fast, we want to, so Ken Gracie's on the line with us. Ken Gracie is the CEO for Parallax. And last week we were talking as a group about how we can do virtual tours for our students of local industry. And Ken and I have spent some time, and Jeff Briggs and I, we've all been talking about how to do this. And so, Ken, do you want to just briefly describe what you think what you foresee the tour looking like? And then let's talk about picking a date, the time, and participants. And we want to do this. So, Ken?
Yeah. Yep. I'm here. Thanks, guys, for the opportunity too. It's great to get a break from email. Yes, so briefly, the plan is, the proposal is to have a 1-hour interactive tour of Parallax over Zoom, where we invite in high school students, your students, and we have in that tour just a very quick introduction of like 10 to 15 minutes of what the business does. And then we have 5 breakout rooms where we can put students in, and they would be talking to our team. Want to encourage them to communicate face-to-face using the tools with our staff and ask them any questions they want. However, our staff would have prepared 5 different breakout rooms. The first one being the CNC shop, so they could look at something like this. That's a robotic gripper, and they can see how we use one CNC to make the tool paths and look at our Haas machines, and ask the CNC guy how much he makes or doesn't make. The second breakout room would be for electronic assembly, which is called surface mount and through-hole technology. Like, how are things like this made? These are products that we make in Rockland. So that's the room 2. Third room would be kind of a reality room with our human resource manager, who's very interesting, active women throughout Sacramento's human resource circles. And her topic would be, what do you want in an employer? What would you ask an employer when you're looking for a job? And then what does the employer really expect from you? A no holds barred reality check. And then the fourth room would be run by myself or probably one of my engineers, and it would be about programming robots in Python using this little gizmo. And it kind of be, that's more of a show and tell, and whatever the students want to talk about. And then the last room would be something really far out, which is when you have zero education, such as my brother, who's the smartest guy I know, how do you go from zero to designing your own semiconductors? Kind of what is the motivating factors that drive somebody to design chips? So we've designed this chip. This is actually our second chip that we've made, and it's using all kinds of automation type equipment. And he's an interesting guy just to talk to because he's very down to earth and barely graduated from Mariloma High School, but has done well technically. So it'd be a 1 hour Zoom meeting. we'd handle up to 100 students, and the dates we have possible for it fall anywhere in the week of May 18 through 20. That's it in a nutshell.
And is there a time of day that works better for your business, Ken?
Does not matter. You know,
Okay.
every day is a Groundhog Day lately for all of us. It just blends together.
That's what my wife keeps saying.
Yeah.
Anyway, so of the participants on the line, do we have anybody that would like to be involved in this so we can start moving this forward? We got to try this because we have several other businesses we want to do this with. So
Absolutely. Yeah, I think that's great.
Yeah, Jeff, this is Pete DeLosa. I think that sounds fantastic, and I would love to get students involved. One question that I have is, when you say, like, are you thinking about one tour for all of the schools in the area, or are we talking about different tours per school? And I ask just thinking that I would actually like to, if possible, offer this to our students at large, not just the ones that are in my classes. It sounds like a lot of valuable information and potentially there for them.
Yeah, you know, we could do it. It's actually a good experience for our staff to do this too, but we could do it up to a certain amount of time that we could make available. So, you know, maybe we could do 2 sets. If we have more than 100 students, we could offer session 1 and session 2 on the same day. You know, one is at 9 a.m. and then one is at 11. And yeah, could we do specific things for your particular class? All the time. We jump into classes where teachers, we might be having a webinar and they have their whole class watching it, or the teacher just says, hey, can you show us that? We offer this all the time, and it's surprising how many teachers actually take us up on it, because we have a lot of cool stuff to show. So, you know, my thought is take advantage of these resources when they're there. Grab them and get your students in front of them.
Mm-hmm.
Excellent. Well, I've got 4 people. It looks like they're interested in talking further. Neil, Brian, Pete, and Craig.
Yeah, this is Matt Wynn. I have students who are already interested. They've already told me, and there some of their parents even want to be part of it.
Well, they can look over their shoulder, don't you think? So what?
That's pretty much it. Yeah.
Yeah, and the topics I just picked, but if you have if you want to see those shaped in some way, I mean, I've heard us talk a lot about a lot of things on this group. So
the topics that you outlined, I thought sounded great, and particularly the one with the HR talking about, like, what do you want from your employer and what does your employer expect from you, I think is really a fantastic thing for young folks to have a really frank discussion about.
Truthfully, I'd probably put them all in there if I had a choice.
I was thinking the same thing.
They'd probably be good for them. Hey, so we're working out the logistics, and we'll get back to the 5 or 6 people that said they're interested right now. We'll work with you. You'll be our guinea pigs because it'll be our first voyage into this space, but I think this is exciting.
Yeah, I'm open for testing and modifying as we go, and, you know, learning with you.
Okay.
And then finally, Steve, before I go on mute, could you share, I'd shared on the chat a program we're offering this summer where we're training about another 400 teachers on Python programming, electronics, and robotics. And it's a free class. It's a distance learning class for teachers that we're running with an organization called the Cyber Education Research Center. They're funded by Department of Homeland Security. And in this case, the DHS is paying for these teachers to get robots, and we're running the class.
And it's free, correct?
It is free.
And
you just have to be a tech educator in America with likelihood of you know, using this in class is what we ask. You know, whether you're teaching with it as a teaching tool, running more like an engineering course or a programming course, or maybe it's something you use in a CNC class as a model around which to build other cool stuff. I don't know. So just share that link if you could.
I believe I just put it on the screen in the chat box. So
thank you.
So Ken, may I ask you a question? This is John.
Hi, John.
Hi. The Python, the programming of your Python controller, how does that compare with the control systems they use on industrial robotics?
So yeah, you mentioned, one of you was mentioning PLCs and like the Fanucs and all those, they have their own software. This is more about embedded product design and creating products. So microcontrollers, as we provide them, are used in everything from drones to, you know, underwater robots to HVAC equipment. You know, behind that PLC is a microcontroller and products that people make. So it's not really, you know, there's some overlap with like PLC type education, but it's really more of a general technical skills experience on the top. But as you dig deeper, ultimately it's about product development, making things.
Okay. All right. Well, thank you.
Sure.
Excellent. I think I hit the wrong thing. So Ken, thank you very much.
You're welcome.
So Dee and Mark Martin, you have a quick thing you want to talk about with Chromebooks, just real fast, and then let's open it. I have a few more things to discuss, and we'll move on. So Dee,
yeah,
ready?
Yeah. Can you hear me? Thumbs up.
Yeah, Mark, go ahead.
Okay.
This is Mark
Yeah,
Martin.
I'm the regional director for manufacturing in the Bay Area. I'm Jeff Briggs for the Bay Area, and Dee, Jen, and I have Autodesk. How many of you, are any of you using Fusion 360 in your classrooms? Okay.
Quite a few are, Mark.
Yeah, I mean, obviously the beauty of Fusion is that you can run it at home on a Mac, on a PC, on your own computer. One of the things we've realized is not everybody necessarily has a computer at home, or it's being accessed by their parents or other siblings. And so we're actually, some of the colleges and schools have been loaning out Chromebooks. Problem with that is Chromebooks will not run Fusion 360. So if you have students who are in that situation, we've come up with a way to run a virtual machine so that students can use a Chromebook or a really old computer. Some really old computers can't run it either, to access Fusion 360. Okay. So I've put in the chat a form that for those who might be interested to fill out. And then what we'll do is we'll ask you to have your students fill that form out, and we can give students this virtualized account to be able to access Fusion 360. Okay.
Mark?
Yes.
Just a FYI on my part to you. I'm teaching CNC machining. At first I was asked to introduce CAD/CAM to my students, and Fusion came along based on it was cloud-based, and I started with that, and I'm learning it as we speak now. But I'm just introducing my students at the end of this semester into that. Last semester I did not. It wasn't really introduced at all. Time was allowed me to do that because they were more at home, and they do have the students that I have right now that didn't drop the class are using Fusion for the last well, 4 weeks, I'd say, and they're doing good with it. And I will continue to introduce it more again in the fall on my class. And I was also I'm also approved to run another class, the next level. I don't know if they'll call it level 2, or I'm not sure about what they'll call it, advanced or whatever. Well, that class will be running Fusion even more than the first class. The first class would be an introduction to Fusion. The second class will be more of it. So you would be designing a part, or I should say drawing a part. I may come up with a design, but they'll be drawing it, running a toolpath, and then we'll run it in the machine.
Okay. So
that's how my class, I envision my class going.
Right. So what we're trying to do is for those students who might not be able to get on Fusion, and with all the remote learning now, is to try to help them get on to Fusion. So if you go to that form, there's a little description, send it out to students to say, hey, if you're having problems getting on Fusion, sign up on this form, and we're gonna be testing it out. And this might be a stepping stone for other software as well. Fusion's nice because the graphics are actually done all off the computer, in the cloud, and but we might look at SolidWorks. We might look at other things where your students would have difficulty running it from home because it might not run on a Mac, but they could still get access to this virtualized machine. And so this is a first step for testing that out. Okay. All right. I know you, Steve, you got other stuff to move on to. Feel free to send me a chat. I'll put my email there as well. You can reach out to me if you have any questions. It's also on that form. If you go to that form, my email's there also. Thanks. Back to you, Steve. Uh-oh, you're not going to make me riff, are you? We've got dead air here.
Yeah, dead air. Sorry, I was muted. Thanks. So I'd like to take just a moment and just open up the floor for discussion about what can we do collectively to help support each other now that you've been doing this online or virtual teaching for a few weeks. And then also, does anybody want to share what does tomorrow look like for your site? I mean, do you have any sense on what's going to be happening come fall? Anybody?
Yeah, Steve?
Yeah.
So I was in a discussion this morning with our IT people and other people on campus, because if we have to go online, we have to figure out how we can do Visio, which is a drawing program. And they came up with a VDI, virtual something infrastructure. But it's a way that the campus is, it's virtual desktop. But basically in a nutshell is that the server is on campus. And so you can take notebooks or whatever, and they don't need the memory. So all they need to be able to do is access the server on campus. So I thought that was pretty cool. It's really again allow us to take some equipment that was not useful yesterday, but with this VDI, we can use it tomorrow.
Cool stuff. Thanks for sharing that, John.
Yeah.
Anybody else have things that they're seeing that's coming? Anything you could use assistance with? Yeah. All right. So next, here's the question for you. Do we continue to have calls on a weekly basis, or would we be better served if we started to do these every other week and give you a chance to keep working on everything you're having to do now, all the new things put on your plate? I'm just looking for ideas and thoughts how to move things forward.
Yeah. Well, Steve, this is Pete. For my part, I kind of like having these weekly conversations. Also, I think every other week could be just as well. And I feel like there's still a fair amount of uncertainty. I kind of feel like I have a way through to the end of May at least. I actually, before the call today, was recording some video stuff using some of the tools I learned about on this call. I was doing some of that Formoc virtual online programming, and then using Google Meets to screen record and do a little video lecture for my kids so they can all do programs. And but yeah, I don't really know what things are going to look like in the fall. There's definitely the possibility of us still being on this weird distance learning thing. I'm really hoping not.
Thanks for sharing, Pete. So
yeah.
So Steve.
Yeah.
Yeah. So John Zay, City College.
Yeah.
Personally, I would like to continue these on a weekly basis, at least through May.
I'm not opposed to it. That's fine.
But also through the summer. And Pete, like you said, we don't know where we are going to be in the fall. And I think it's very important that we continue coming up with contingency plans so we could have a better transition, a smoother transition from going face to face to online. And I think we just need to brainstorm different techniques that we could work with our students on if we have to do distant ed. You know, it's going to take, like I said earlier, a lot of thinking out of the box.
Thank you, John.
Yeah.
You know, we only have 4 weeks left of school after this.
Yeah.
So to go every other week would kind of just really reduce our exposure to anything new that we can come up with.
Okay.
That would actually help with this school year. Beyond that, then every other week probably would be okay.
Yeah, through the summer months.
Yeah.
Ready for the fall. Probably by then you'll have a better idea of what fall might look like.
Yeah, Steve, it's Roy Ingram, Sierra College. I'm in support of doing weekly and through the end of the semester at least, so we can sort of stay up to speed on each other's skills and what we're going to do for the fall. As far as us, everything is still planned to be online for summer, and then the fall, they've said that they might do exceptions for us with small reduced class sizes or staggered lab environments, so we can still get the students through the labs, but just in a reduced headcount fashion. So, but that is not etched in stone by any means, and obviously we'll wait to see what happens as states start to open back up, see what happens with the infection rates and things.
Yes, subject to modification. And before we go on a little further, thank you, Roy. I've invited Roy to spend a few minutes next week, just like John did today, talking about the mechatronics program at Sierra College. So that's one of the key items on our agenda for next week.
Cool.
Any other thoughts? What kind of support can you, or you email me directly and we'll talk and we'll figure out something, we'll find something. I know this is challenging because my wife's a school teacher and she's a special ed teacher in elementary school. Our dining room table has turned into her classroom, and it's a lot of fun to watch her students. But it is definitely a challenge, and I can only imagine if I was back in the classroom how I would teach a plastics manufacturing class or a construction class or an architecture class.
And Steve, if I may add, this is Dee from Autodesk. I understand it's a challenging time for all of you, and I'd like to offer, if any of you have a hard time to fill your class sometimes, and if you need a guest lecture on fusion or on generative design, please let me know, and I will be happy to do that.
Cool. Thanks, Dee.
Writing this down.
Yeah, and then I'll put my email address in the chat, so please feel free to contact me.
Yeah, a question for educators. Do we get any kind of discount, or is there some type of educators platform for Autodesk, or do we buy the full package?
For software, the good news is that the whole learning materials and then the software, all the software is free for educators and then the students. And including the cloud credits for generative design, it's all unlimited for educators and students. So there's no charge for you guys.
Cool stuff.
Thank you for that.
So Steve, John here, I have another example of thinking out of the box.
Love to hear it, because that's what we need.
So I was talking to CRC, their construction program, right? It's like, okay, how do we build a house when we're distant in? I said, well, so why don't you just get a bunch of balsa wood and an X-Acto knife and give it to all the students, and they have to frame a house to scale, right? And they got to put the headers in the right place. The studs have all got to be on 16/8 centers. I mean, it's not like they're actually doing it, but they're understanding the principles, and they're understanding how to use a tape measure and how all this fits together, right? And again, it's not the best, but I like to say it's better than poking the eye with a sharp stick, okay?
I used to do that in my architecture classes, exactly what you're talking about.
Right.
John, I really liked your idea, what you said about giving the kids a wrench and some bolts and and having them break the bolt by over tightening it. And I thought, like, I think you're on the right track there. Just that for folks that haven't ever worked a wrench before, there is something that is kind of intuitive, and it takes breaking a few bolts before you get the feel of like how hard can you torque a 1/4 inch bolt versus a 1/2 inch bolt.
Exactly. Yeah.
Throw some brass bolts in there too and see what happens.
Sure. And then, you know, we went to last fall. Yeah, we were over at Cal Expo for a career day, and we were having the high school students do copper flaring. And it's amazing how many of those kids didn't know how to hold the tools, because kids don't fix their bicycles anymore like we did. And so I think just being able to hold those tools, there's a lot of knowledge gained in that itself, right?
Yeah.
I'm in complete agreement. One of the big things we like to have in circuits and physics is they have to be able to use a multimeter and blow fuses constantly. I'll go through 100 fuses every semester just to show them this is what happens when you short a circuit. It's needs to be hands-on like that.
That's true. And the other thing,
we had the problem with that kind of thing with simulators. You know, we use Multisim. I've suggested that in the past for electronic circuits, and really you can overcurrent a lot of devices and they don't smoke, they don't blow up. And like I said, just to blow fuses in real life and realize that what you're doing is wrong, I think is one of the biggest learning processes. It's the struggle or the learning by failure. You learn more by your failures than your successes, and I think that is the essence of the mechatronics programs. I saw what John was showing there with his program. It's the same stuff. You have to get them involved with it. And so I'm considering sending my students full kits of electronics in the fall. You can get a pretty good kit for $50-$60, and it's cheaper than most textbooks, and you would learn probably 10 times more than most textbooks as well with a simple kit and a multimeter and a few parts. So that's just some of the stuff I've been considering.
So Roy, how are you going to manage that? Are they going to have to turn those back in at the end of the semester so you can use them again in the spring or another time?
No, you know, I found an oscilloscope, pocket oscilloscope for $15. I have found multimeters that are within the $20 range, and then the electronics covering transistors, resistors, LEDs, some basic IC. All of that can be in the under $100 range. So I don't know what the school would pay for versus what the students are going to be responsible for. And but I could see a pretty good kit for a reasonable price, and then ship it either through like an Amazon type of purchase, or we as a school acquire it and package it with our administrative assistants helping us out.
So maybe that's something we can work on collectively this summer if different schools have a desire to do something like that, buy in volume and get a better price. Just
I think
really being out of the box.
Yeah.
Well, any other parting thoughts or suggestions?
I had one, Steve. I kind of addressed it to John and I'm not sure who else when they were referring to bringing bolts and nuts in with the wrenches and testing them out so students would get an idea how much torque to put on something. In regards to that, I think it might be also an idea to have some technical specs on there so they know what it should be before they even try to break it.
I like that, Neil.
You know, it's okay to go break 100 bolts, but if you don't have to, because you have technical data to tell you what to do, you know, you save a lot of work that way, and it's also training them, a student, where to get that information.
Yeah. But Neil, I actually want them to break the bolts because I want them to develop that feel in their hands, right? Besides, I got stock in a fastener company. So,
All right, I'm losing control again.
so Roy, on the chat, I put in a link. It's some circuit design. So it's a circuit construction kit. But what's cool about this one, if you overamp it, I think the battery catches on fire. So that might be something good for your students. Yeah.
Yeah, I totally like that, John. And this kit, you're saying the battery catches on fire. This is a nice simulation kit you're talking?
Yeah, it's just, you just do it online. It's really cool.
All right. Yeah, that's a good idea.
Yeah.
Well, absent any other thoughts, shall we call it a day and then come back again next week? I guess it'll be Cinco de Mayo next Monday or Tuesday, right?
Oh.
I got an idea. As far as your whole, like, if you overload the circuit and the fuse, you know, goes and everything, Roy, you could just go ahead and do little videos of that and then do them in the form of a quiz. And it's almost like choose your own adventure, but with circuitry.
I'm liking it.
I got it. Yeah. Yeah. I think, yeah, one thing with overhead with making videos, I don't know. I'm not much of a, creating my own videos and posting them. That's not my expertise. But I think I like the idea of having them quizzes, seeing a real life situation and having to troubleshoot it.
I'll be honest, I'm not much for making videos myself, mostly because the video camera on my cell phone is dead and doesn't function. But what I have done, I do this specifically with the oxyacetylene homework because, you know, if you don't do it right, things go boom. And so students will answer a question, and if they answer it wrong, depending on which wrong answer they pick, it will pop up a video of what actually occurs if they were to do that incorrect action. And so that's what I mean. It's a little bit almost of choose your own adventure. But the videos, I just pull them off of YouTube. So they might have something on there. I mean, obviously that's not really a this semester thing because God knows we're just trying to get down to the wire and all make it through, but might be something to think about for the fall.
Yeah, thanks, Alita.
You're welcome.
Well, shall we ring off? Go about our day?
Yes, sir.
Regenerate for tomorrow?
Yes.
Sure.
Thank you. Thank you, everybody.
Thank you.
Thank you all.
Thank you all.
Get it.
All right.
Thank you all. Take care.
All right.
So, Steve, can
Thank
you
you.
hang on for just a second?
Yeah, I'd be glad to.